this introductory video on epidemiology in SPSS. Analyze epidemiology data in SPSS. There are very important things that you need to know. And the first thing I'm going to show you is to generate a new variable. It's very important to know how to transform a variable in order to have a new variable so that you can use it in order to analyze the data the way you want. The second thing I'm going to show you is how to perform chi-square test, which is very useful test in epidemiology, which is used in order to analyze degree of dependence between qualitative variables. We'll also show you how to compute and interpret odds ratio and relative risk, which is a measure that is used also in the analysis of a disease to show which factor of the disease is increasing or decreasing the risk of the disease. So for the purpose of this video, we have a database containing data on the BMI, the body mass index, and some other parameter that can influence the body mass index. We have the study level, we have gender, we have date of birth, we have the region that are factor that we are going to use in this video in order to analyze the body mass index. So it's the first time you are watching one of my videos, do not hesitate to subscribe to the YouTube channel and let me a thumbs up. It will be very interesting to know that for I'm making in order to improve your statistical level. First thing I told you I'm going to teach you is to generate a new, so how to generate a new variable in SPSS. So we have variable BMI, which represents body mass index, which is calculated by dividing the weight kilogram by height meter. So the measure of BMI is measured by meter square. We are going to generate a variable that we will call obesity stages, which have three values. So the first value of our variable obesity stages is underweight, which is the stage in which we have BMI less than 18.5. For the second value that our variable we take is normal. Normal is when BMI is between 80.5 to 20. So the third value that our variable we take is obese, which is the stage in which the BMI is more than 25. So how we generate a new variable? So to generate my new variable, I will go to transform. I will click on compute variable. So as we click on compute the variable, we have the possibility to choose the target variable, and your target variable we should not start with number, and we are not allowed to create a variable with words separated by space. So I'll call my variable obesity stages. Stages. First value that my variable is going to take is 1. My variable will take the value 1 if. So I will go in conditional case selection here, optional case selection condition here, click on if. So my variable will take the value 1 if I include the cases. I click on include if case satisfies condition. So I'll select my variable BMI. So my variable obesity stages will take the value 1 if BMI is less than 18.5. So and then click on continue and then click on OK. My variable obesity stages have generated the first value, which is 1 when BMI is less than 80.5%. So set time, go to transform, compute variable. I will give my variable value 2 if condition BMI is more or equal to 80.5 and BMI is less than 25. Then click on continue and then click on OK. Change existing variable OK, and we have generated the second value of our variable obesity stages. Click on transform to create a third value of our variable. So the third value is 3. Variable will take the value 3 if BMI is more than 25. So you then click on continue and then click on OK. OK, our variable obesity stages has been generated. I can copy my value obesity stages and paste in label section so that the label of my variable will be obesity stages. So I can give value to my variable and said earlier that our variable have 3 values. The first value is 1. The label of this value is underweight. So the first value will be those attributed to those that are overweight. The second value of our variable is normal when BMI is between 18.5 to 25. So the third value of our variable will be 3 and the level of the variable will be obese. Click on add and then click on OK. 3 modality of the 3 value and label of our different variable have been created. And to see if whether or not our variable has been successfully created, we'll go on analyze and then go to frequency to select our variable obesity stage and then use the arrow to throw it in to variable section, and then click on OK, and we see that statistic related to obesity status has been generated. We see that there are 636 persons in our sample, so 2,538 individuals, and we have 636 persons on the weight. We have 1,405 persons that have normal weight. We have 267 persons that are in obese stage. We also have a percentage of valid realization. We have a missing value, 230 missing value in obesity stages due to the fact that the variable BMI has this number of missing value per person in the sample that BMI have not been recorded in the data. So we have weighted percentage of valid value. We have 27.6% of our sample that are in underweight section. We have normal that represent 60% of our sample, and we have 11.6% of our sample that are obese. Here is a descriptive statistic of our variable overweight. How to, for example, see if whether or not obesity stages have a link with the gender. So to know if whether or not obesity have, for example, gender, we'll perform a chi-square test, because obesity and obesity stages and gender are qualitative variables, and to perform the link to see whether or not there is a link between two qualitative variables. Chi-square test is one of statistical tests that can be used in order to analyze the obesity. So let us run the chi-square test in order to see whether or not obesity stage have a link with gender. So to run chi-square test, let us go in analyze, then go on descriptive statistics, and then select cross tabs. So when we select cross tabs, we will select our first variable, which is BMI stages, and put it using this throwing in the row section using arrow. So we'll select second time our variable gender, and then throw it into the column section. And then we have the possibility to set some statistic that we have to have. So we will select the chi-square, which is the statistic, one of the statistics that we need to analyze whether or not this stage have. Click on continue, and then click on OK, and you can see that the cross table of these stages and gender has been generated, and we have cross table here, which show the representation of obesity according to the gender. Here is the result of our chi-square test. We have a Pearson chi-square value of 84.008, and we have 2 degrees of freedom, and we have the asymptotic p-value of 0.000. P-value is 0.000. What is the null hypothesis of the chi-square? So the null hypothesis of our chi-square test is that our variables are dependently correlated. So the null hypothesis is that our variables have a link. There is a link between overweight stages and the gender. P-value of our test is less than 5%, which is the threshold that is generally chosen in social sciences and epidemiology in particular. So our p-value is less than 5%. So that we reject the null hypothesis of independence. The null hypothesis of our chi-square test is rather the independence between our two variables. So the null hypothesis stipulates that there is no link between gender and obesity status. So as our p-value is less than 5%, we just reject the null hypothesis, which means that there is a link between two variables, gender and obesity stages, meaning that we cannot accept that gender and obesity stage are independent. The conclusion of our chi-square test is that there is a link between gender and obesity stages. It can mean that in the class of person that are obese, cannot equally have male and female person. So we'll improve this analysis using odds ratio and relative. So let us also make a chi-square test to analyze the dependence between obesity stage and the study level. So we have three study levels. We have nursery, we have primary, and we have secondary. For example, we also have person of these three levels of study: nursery, primary, and secondary. So how to perform a chi-square test? As previously shown, we go on descriptive analyze, descriptive statistics, cross tabs. So we have the cross table. We will remove our variable gender and put in column section the variable study level, and then we have already select our chi-square test. We click on continue, and then click on OK, and the cross table of the variable tabulation of variable obesity stage and study level has been generated, and we have our p-value of Pearson chi-square, which is also less than 5%, meaning that the study level is not independent to the obesity stage. So we can assume that distribution of obesity is not the same in each study level. We can also perform chi-square test for any other variable that we want, or we can create using variable generation. So we'll end here for the chi-square test and introduce to you the odds ratio, which is a measure that is used in order to analyze risk of the disease. So we consider that the odds ratio is used for a binary variable. So that's the first thing you need to know, and it's used to analyze if whether or not factor increase or decrease the risk of having a disease. Purpose of the odds ratio and relative risk I will generate a binary variable based on obesity stage. So I generate a variable called obese, which will take a variable 1, BMI is more than 25, and 2 if BMI is less than 25. So this variable characterize a disease, which is the obesity, which only have two variables. So I will generate a variable going on transform like previously, and then click on compute the variable. My variable will be called obese. The first value that my variable will take will be 1 if the BMI is more than 25. I will consider that more or equal to 25. I will consider that the patient is obese. So I'll also click on transform, keep my variable obese, into the value 2 if BMI is less than 25. Then click on continue and then click on OK. Change existing variable OK, and we see that our variable obese has been generated, and I will keep the same label for my variable here, and then create a value, and my variable will take a value 1 for obese and take the value 2 for non-obese. Then click on OK, add, then click on OK. How to compute the odds ratio of obese according to gender. So odds ratio and relative risk of obese to gender will give us information whether or not being male or female increase or decrease the risk of being obese. So we have run chi-square test in order to chi-square test shown us that obesity have a link with the gender. So odds ratio will help us know if whether or not being male or female is a risk or protective factor for obesity. Using the variable obese that we have just generated, that is taking two variables, obese and non-obese. So how to compute the odds ratio? We proceed exactly the same way with chi-square test done. So let us go on analyze, and then go on descriptive statistic. We have cross table. So we have also select column obesity. I will remove all my variable to the variable section. So variable that we put in column is the variable representing the disease. So our variable representing the disease here is obese. We select our variable obese and put it in column section. We will analyze the factor if our variable obese according to the factor, the gender factor. So we select our variable gender and put it in row section. So go on statistics and deselect chi-square. We also will rather here choose risk statistic to analyze odds ratio and relative risk. And then click on continue, and then click on OK, and we see that our cross table of gender and obese variable has been generated, and we can see here class table with the 95% confidence interval, which is between 2.19 to 6.11. Meaning that odds ratio of our variable is equal to 4, which is at 5% level more than 1, because the confidence 95% confidence interval have value that has more than 1, and the value of our odds ratio is more than 1, 4.27. It means that being female increase the risk of being obese. That's the interpretation of odds ratio. Our relative risk is also more than 5, mean that odds ratio, for example, of 4.7 mean that in female population 4 times likely to be obese than male. So the interval confidence interval of 2.98 to 6.11 mean that in our population female are 2.98 to 6.11 times more likely to be obese. So that's it for this video, and I hope you have very well helped you understand the first notion in epidemiology, and we'll see you next time in the other video.